Hey there, so back in September I flew this small 3D printed rocket that was a follow-up to DART. A rocket that had mixed results, and that we will talk about soon. DART 2 went much better, and it actually made it off the pad, but due to me doing a bad job at packing the parachute, it went screaming into the ground. But as we start down this path of working towards not only a space shot, but Project Vulcan, we will need a test bed, and that's what this is. This is a test bed for Project Vulcan. It is the first out of 3 vehicles I will build and fly during this project. And today we are going to talk about how I built this rocket and didn't use a single piece of fiberglass, cardboard, or carbon fiber. Okay, so I'm sure the first question on a few people's mind is how do you make a rocket without using any conventional materials? Well, here's a hint. This is Terran 1. It was made by Relativity Space and is completely 3D printed by their massive 3D printer called Stargate. The vehicle is powered by 9 engines on the first stage and 1 vacuum-optimized engine on the second stage. Both their engines are also 3D printed, which is becoming a very common practice in today's industry. Unfortunately, on the first launch of this vehicle, it did not make it to orbit due to a slow response of the main valves, leading to the engine failing to fully come up to thrust and the vehicle falling back to Earth. One thing this already awesome launch did was verify that a 3D printed rocket can make it through max Q and the high-stress environment of launch. So I decided to try making a fully 3D printed rocket of my own. But this time, we're going to make a few changes. First, instead of being only 29 millimeters in diameter, we will make it 54 millimeters in diameter. This will help with the parachute packing issue that I had on DART, and will also just make a lot of different operations easier. Second, we will be printing the fins separately from the vehicle, then tacking them on later, instead of printing the vehicle with the fins pre-attached like I did with DART. This solves some problems that I can have with my CAD. We are also going to be making the parachute bigger, going from 12 inches in diameter to a full 36 inches, along with using a Nomax fireproof blanket to shield the parachute instead of a single-use wadding. We will also be shrinking the size for the motor from 29 millimeters to 24 millimeters. Now, typically this would accommodate a lower power E motor, and this was the plan, but there was a slight manufacturing error resulting in the nose cone being printed solid. So that E motor will only get us up to about 60 feet. That's awful. So I will also be increasing the motor to a 24 millimeter F35. Now, because we are tacking the fins on, we do have to put consideration into getting these fins on straight. In the past, I have used some different methods to get the fins on straight, and I decided to run a few tests to see how well these different methods work. The first method was hot glue. I have used this on a few rockets before, including DART B1, or Block 1. I would use the hot glue to tack the fins to the airframe, and then I would fillet them to the airframe using JB Weld, which, as a reminder for you skeptics, can survive going Mach 2. I will link that video in the description. This works, but it doesn't quite keep the fins as straight as I would like. I'm certainly concerned with the structural integrity of the base bond. The second thing I tried was superglue. This is, in some form, has been used by the likes of Joe Barnard and Braden Carlson and has survived some pretty extreme cases like going Mach 3 and pulling 64 Gs. Rest in peace, CBDB. But in the end, I decided that it dries a little too fast for me to position and move the fins around, and they would end up less straight than I wanted. So, in the end, I designed and printed a fin jig, and that's what we will use. On this fin jig, I didn't do the best job of designing it, and in the future the slots for the fins definitely need to be a little more snug on the fin. Okay, now with all this testing and design done, we can now build this thing. After I printed out all the parts, I took the fins, main airframe, motor tube, centering rings out to the shed and started a big epoxy operation. But as every good rocketeer knows, the first step to any high-strength epoxy operation is bond prep. Now, a certain person I know conducted some tests recently related to this, and if you want to learn more, I'll link his video down in the description. But I have a certain level of access to his content, and so I know a little more than most of his viewers. But what his test told him was that for bond prep, IPA and acetone are really good, and sanding is pretty good. Once he publishes his video, I'll link it in the description, but I don't want to get in trouble with him, so I'm going to leave this part pretty vague. So, I grabbed my IPA, and I didn't have any acetone, so I decided to just forego that part. But I wiped down the area where the fins would go with the IPA. I just got a paper towel wet with the stuff. After that, I sanded the crap out of the body tube and the base of the fins. After that, I mixed up my JB Weld and got to work. By the way, as everyone in the rocketry community knows, it is a heated topic on what type of adhesive you use. Shout out to my podcast, Go for Launch. That will be linked in the description down below. I have an upcoming talk on adhesives, and if you want more of my podcast, rockets, aerospace, and adhesives, along with epoxy strength tests, you can access my Patreon page in the description down below. Because, guys, YouTube finally trusts me. After almost 2 months of uploading videos, YouTube finally trusts me to link stuff in the description. So definitely go check out a few of those links, and maybe even go join the Patreon. There are multiple different benefits you get with each tier. But if you just want to participate in the conversation for the podcast, we do have a $1 membership for people who only want to participate in the podcast. It will be free soon, but I gotta figure out that part first. Or there is also our app where you can join the conversation. Okay. Now, back to building the rocket. During the mixing of the epoxy, I found that JB Weld is a lot thicker than I remember. And I mean thick. 3 C's, no K. I added a small amount of epoxy to the base of each fin, and then put them into the fin jig, and after all 4 fins were done, I started preparing for what truly determines on every rocket if it survives or not. Fillets. And very quickly, before anyone starts roasting me for these terrible fillets, I would just like to say I am not a pro at CAD, and I made the idiotic move of just making a fillet tool in CAD and saying, yep, that looks good enough. And while that can work in many applications, it does not work with fillets. So going forward, we will be designing custom fillet makers for each rocket. But I mixed up another batch of this stupid thick epoxy and poured it onto the vehicle. And I would like to remind everyone, I am not a pro, and please do not roast me for these fillets. Brayden, Rocket Vlogs, I'm looking at you. But after I put the epoxy on the rocket, I smoothed them out with my terrible little fillet makers. The next step was epoxying the coupler into the airframe, and this is when I discovered that I had once again had problems with my 3D model. It caused the coupler to be a tiny bit smaller than it should have been, so I wrapped it in a thin layer of tape, and that seemed to do the job. After that, I coated the part of the coupler that wasn't wrapped in tape with epoxy, and I pushed it into the rocket. And naturally, all that epoxy got squeezed out and built up on the airframe. So after I was done putting this into the rocket, I had to do a little bit of epoxy cleanup. Because as everyone in rocketry knows, epoxy will get everywhere if you let it. This rule also applies to RTV, or room temperature vulcanizing silicone. You'll see what that is sooner or later on this channel. Finally, I need to epoxy the nose cone into the upper section of the airframe. So I put quite a healthy amount of epoxy on the coupler, and by this point I was quickly running out of epoxy. So next time I think I'll buy a few of those massive tubes of JB Weld. After that, I pushed the nose cone into the airframe, and once again, I had to do a lot of epoxy cleanup to prevent a big mess. The final step is painting, and I decided to go with a base white color and then a really cool blue scheme with an arrow and stripes. It's sick, and I think it's an awesome paint scheme, and as long as the dirt doesn't ruin it, we're not going fast enough to ruin this paint scheme, which I'm very glad because I'm very proud of how good it looks. I also painted the nose tip black, which I think looks sick. Now, I do plan to fly this at O-Rock, but because of darn winter, that club has closed down all launch operations. So, April will be busy, so make sure you have subscribed so you don't miss April Mania. Yes, that's what I'm going to call it. I will also be posting a lot more build videos, and the first podcast video is going to be filmed soon, so get ready for that. I'm also talking to a few fellow rocket YouTubers if they would want to come in and join the conversation. That will probably be really fun and probably kind of chaotic. But until then, my name is Liam P, and I will see you next time.